So the rectangular approximation method can also work from tables of values, not just from graphs of functions. So here, this is blood dye concentration within a bloodstream, used as a way to check for blockages in arteries. And over time, this is data on the concentration of that dye within the bloodstream, uh, so many seconds after an injection. And we can even think of this that if we wanted to graph concentration on the y-axis and the time in seconds on the x-axis, we would have a graph where it comes up and then comes back down. We just don't know what's happening in between those. So we are kind of limited that if we wanted to use rectangles, we would not be able to use the midpoints to decide the height. We would have to use either the left point, the left of the rectangle, or the right of the rectangle. And that's kind of what the decision is that has to be made. So if I wanted to say from 5 to 7, well, if here's 5 and here's 7, the height of my rectangle is determined by the 5. So from 5 to 7, the width is 2, and the height was determined by the 5, which is at 0, because that would be our first rectangle. This is, again, I should say for LRAM. The next rectangle would be from 7 to 9, where the width is 2, and then my height is determined by the left, which is 7, which is 3.8. And my next rectangle is from 9 to 11. Well, that has a width of 2. Height's determined by the 9, which is on the left side, which would be 8. And I would just keep doing that all the way down. And then I could figure out all those areas. So adding those up, so on to the end. If I were doing RRAM, my widths aren't going to change. What's going to change, so I have a width of 2 from 5 to 7, but now it's the 7 determining the height of 3.8. If I go to the next rectangle between 7 and 9, that still has a width of 2, but now the 9 determines the height at 8. And then my next rectangle from 9 to 11 still has a width of 2, but now the 11 determines the height, because that's on the right, of 6.1, and so on.